So let me walk you quickly through the setup here. I've got one of the little switching power supply modules. It's wired up to bring 170 volts through the yellow wire here to the smart socket board. Its ground is brought over to ground on the board to create a ground reference. The ground from the board is coming over here to a TTL level RS-232 breakout box. The orange wire here is picking +5 off the laptop, back around to power the PIC microcontroller underneath. The black and gray wires are the transmit and receive here that go from the smart socket board back around to the RS-232 TTL adapter. I'm bringing in a ground for my external 12 volt supply and +12 to the converter board. Currently this is powered off. At this point we should have power on the tube, the +5 volt power on the tube. I'm using the TES calculator from Taylor Electronics because it's got this neat little controller utility built in. We can go down here to the smart socket. We can bring up this little utility here. Sorry, I'm trying to shoot this handheld. And log traffic. And as I change characters here, I believe this will go ahead and send those characters out to the smart socket. So the thing I really need to do here is apply power to get the 170 volts to the tube and see if it lights up. I've gone through the wiring several times. I've ohmed everything out. I'm not going to pass the high voltage accidentally back onto the 5 volt bus back in here and blow my laptop up or take this board out. This should be safe at this point to bring up. So we should have high voltage now on. And why am I not seeing anything being displayed? Oh, I forgot a key component here. I have to look over and see it. I got to tell it what COM port we're using here, and of course I'm trying to do this with one hand. We're talking on COM 4. Hopefully now, if I go in here and type a character, it'll make it. Ah, yes. So I've gone in, typed a character in the box here. The test calculator has formatted that as the string that needed to be sent. In this case, the string it sent is right here. $B7, M is message, and the A for the letter A. That got sent to the tube and the tube lit. So I should be able to hit the keypad here, or laptop 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, Z, X, C, B, N. Yes, that's the B, N, M, A, S, D, F, G, H, J, K, L, Q, W, E, R, T, Y, QWERTY, U, I, O, and P. So at this point, we have one known working smart socket board. We've tested 3 of the switching power supply modules. I've actually assembled and tested 3. We did one in an earlier video. I've installed the TES calculator on the laptop here at the bench to bring this whole thing to life, and I guess the next thing I need to do is basically get power and control signals. I'm sorry, this is being shot handheld. To these other 2 smart socket boards that have been assembled, and see if we can basically get 3 tubes up and running. I just have to build a bit of a wiring harness to bring this all together, which I'll have to go do next. But this is a really good sign here that we are able to send messages to the tube and have them display. You know, there's all kinds of options in the smart socket for fonts and everything. I will play with those later. This really was the first thing I wanted to play with. I've just noticed something over here in the TES calculator. Start 48 to 57, delay, animate. Oh, sweet. We can actually see it stepping through numbers here. So that's at 100 milliseconds delay per number, and it's counting from ASCII 48 to 57, which is 0 through 9. I'm going to slow it down a bit. And let's walk it through the entire character set. I'm going to step from 0 to 255. Okay, the minimum it'll send is. So I'm going to send it the sequence. Character 10 decimal to 125 decimal seems to be the maximum range it'll take, with quarter-second steps in between. And let's just see what it sends to the tube. Hopefully sooner or later it'll hit something here the tube can display. Like I say, the font and the tube only have so many characters. That's pretty nice to see. Of course, it's still animating here. Okay, it's showing me. I see now. It's going to start with 48. That's quite interesting. Let me turn animation off. I know this has got a default font here, so I haven't played with this at all. I'm going to write whatever character set to the tube. Character set's been uploaded to the pic. Let's go ahead and animate again and see. Of course, I didn't change the font. So we just have a font editor. You can go in and I'd have to remember the command to change the font to the tube. Or to the smart second. I got a lot of reading to do here, but basically you can see what's going on here is core configuration's working. Rigol supply is, see, with all the segments off, it's 0.12 watts. It just jumped to 1.3. I saw 1.8 watts there come up for a second. Current draws dancing between 120 milliamps on the 12 volt supply. There's 90 milliamps sitting there with the Z lit. I'd have to get an ammeter in circuit here to see the actual draw to the tube. But no, this is a really good sign. This is definitely progress on the build. I guess I could sit here and talk all night about this. But I'm very happy to see this work. So, one step at a time. It's interesting in the camera, there appear to be hot spots in the center of the segments. And although those are a little bit visible to the naked eye, they're not nearly as bright as they appear on camera. Anyhow, pretty pleased. I will stop recording here and continue to move forward with this. We'll talk soon. Bye. So I've been playing a bit with some of the fading effects, and I'm just cycling through user-defined characters and regular characters here on the tube. And I'm just going to let this run as a burn-in. I'm seeing the current jump as high as a 1/4 amp off the 12 volt supply. Again, not a big deal. I really need to get an ammeter, I guess, in circuit and get an idea just what the total current draw here is. I guess honestly everything I need to know is in the power calculation on the DC power supply, and then I'm seeing it hit a max of about 3 watts. You know, given the efficiency of the board, we should be fine here. So, you know, if the total power being grabbed by the system is 3 watts at peak, the board, you know, the little DC to DC converter board, I think is good for 5.5 or 6 watts tops. And so we're not, you know, we're not exceeding really 50% or maybe 60% of its maximum rating. And in this little demo mode here, that's not continuous, so this isn't a bad thing. I'm just going to let this sit here and bake for a while, and we'll see what we get. So, anyhow, I'll talk soon.